All right, welcome to the next lesson on probability tables, which we found out, I think, a couple lessons ago, or last lesson, could also be called Carnot maps, which is what they're called in year 12. All right, so this is a Carnot map. Carnot, as in a person. Carnot map. All right, so we're going to have a look at how they're created, and then we're going to look at some uses for them. So this is a Carnot map, and it's created from a Venn diagram. So you can see on the Venn diagram here, there are 4 areas. Not A, intersection not B. So not A or not B. Inside here we have not A, intersection with B. So this is where everything that's not A intersects with everything that's B. So it's just this crescent shape here. The converse is over here, A intersection not B. So the not B intersecting with the A, which is this, and then obviously A intersection B. So A or B in the middle here. There are only 4 areas in a Venn diagram that has 2 circles, all right? So let's have a look at how they go into a Carnot map. So this is a two-way table on the right-hand side here, and you can see A crosses over with B. So this would be that middle part, A intersection B. Now I've labelled the Carnot map as B or not B, because as we saw in the past lessons, there are only 2 events. When I'm talking about A, it's either A or not A. If I talk about B, it's B or not B. It doesn't matter that there's this possibility over here when talking about B. All I'm interested in is B or not B. Okay, so then this column here, where I'm intersecting not B with A, so we can see A intersection not B, so we just write that down, A intersection not B. And we can see that that maps this part here into the Carnot table. All right, so then we just fill out the intersections from the two-way table. So this is not A, B, this is not A, not B. All right, so I'd write that into your book, that's a command, all right? Because we're going to use this from this point on to do some pretty important things. All right, now, what we're interested in doing here is some extra bits, and you might see these extra bits around the outside here, okay? We're going to fill those in because those are also some surprising results. When we normally talk about events in a Venn diagram, we talk about the A event or the B event. But we have these intersections and it starts to get a bit messy. But let's flip back to the Venn diagram for now. If I was to add together this result and this result, that would give me all the results in the A circle. So if I go back to this Carnot map here, if I was to add together A intersection B, which is the middle, with A intersection not B, which is the crescent shape here, I'm going to get PR of A. All right, so going across the column, across the row, shows me the probability of the A event. All right, same thing happens with the next row down. Not A intersection B, which is that part there, added together with not A or not B, which is that part there. So that gives me everything that's not in the A circle. So that's the PR of not A. So that's the A events. Going down the columns, we get the B events. If I have the middle section together with not A intersection B, I get everything in the B circle. So that's PRB. And the same thing across here, I get PR not B. All right, now those are the big things from this Carnot map, and it's what allows us to calculate some probabilities based on partial results. All right, now the last bit is this bottom right corner in the Carnot map. Obviously, if I add together the probability of getting A or not A, I would get everything all at once, which is a chance of 1. Something must always happen. And the same across the bottom. If I add together the chance of B and not B, that's everything. So I still get the same chance. All right, so this Carnot map shows us all possible results in a Venn diagram. And it's just a neat way of putting all those results and being able to transfer Venn diagram information into a table. All right, so let's have a look at a question. And while we do that, you also want to put this Carnot map into your notes book, and you might want to add the Venn diagram in there to show that the regions come from there also. So here is the question. It says, if A and B are events such that here's the chance of A, here's the chance of the intersection, and here's the chance of that. Find this and find all these different sections, all right? So we need to be able to use this Kano map to help us. So let's draw a table. It needs to have so many rows, so many columns, like this. All right, so we'll have A, not A, B, not B. All right, and then we have these extra bits out the side here as well. Okay, so this is always 1, doesn't matter what the results are. So let's just fill it in. So we've got the chance of A, that's 0.7. So that's out here because that was in this area here. A intersection B, so that's in here. And we have not A intersecting with B, that is this one here. So we just fill in the results we know, and then we use what we know to calculate the missing parts. So I know that this box added with this box equals 0.7. So that indicates to me that this box needs to be 0.3. All right. I know that this box with this box equals 1. So then the missing box is also 0.3. All right. And we just keep filling in as we need to, like that. So then I know that this box with this box equals 0.3. So the missing box needs to be 0.1. I know that these ones add to make that, and these ones add to make that. So then we can just do that. All right, and the last check is to make sure that this works. 0.6 plus 0.4 equals 1. Perfect. 0.7 plus 0.3 equals 1. All right, so we've filled out the Kano map. Now we can pull the information we need to answer these parts. So A intersecting with not B, find it on the original map up here, which is this 0.3 here. All right, so this is why it's helpful to have this original map, which has all the regions named in it, because questions might ask you in this terms and you might not remember. Okay, so put it into your books. Chance of B is the bottom one in the B column, 0.6. Not A intersecting not B is this bottom right one inside the thing here, so that's 0.1. And A union B. Now this one's a bit tricky, because union B, we have to go back to our addition rule from last lesson, and the addition rule says that union B equals chance of A plus, whoops, made a couple of mistakes there, chance of B, take away the intersection, so we don't count it twice, okay? So the chance of A was 0.7, the chance of B was 0.6, and the intersection was 0.4, so we should have 0.7 plus 0.6 is 1.3, take away 0.4 equals 0.9. So the chance of getting A or B is 0.9. And if we look at this result here, where it was not A intersecting not B, you look back up here at the Venn diagram, this one here is that 0.1 result, which should mean that if we don't get the thing out inside the circles, we're getting 0.1, so the leftovers are 0.9. So we could have worked it out like that, but it's probably safer to turn to our little formula here to calculate unions. All right, so that's an example of a question and why it's so important to have that Kano map, the original one, drawn into your notes book so you can refer back to it. All right, let's have a look at another question. I'm just going to position it next to this so that we have room and can see both at the same time. All right, so records indicate that in Australia, 65% of secondary students participate in sport, 71% are Australian by birth. They also show that 53% of students are Australians and participate in sport. So there's an A event, which is sport, and a B event, which is Australian by birth. All right, so we've got our two events. We can draw our little Kano map here. Like that. Like that. Okay, so this bottom right corner is always 1. Now, we're going to have A, not A, B, not B. All right, so let's just start filling in. It says 65% participate in sport. So we'll make that the A event. So this is 0.65 is the A event. So that means that not A is 0.35. All right, so 65% participate in sport, 35% don't. 71% are Australian by birth. So this is this one here, 71, and that means this is 0.29. All right, and then it says 53% are Australian and participate, and that is this first box here, so 0.53. All right, so we've started to get some ideas here about where we can go from there. So we just start jotting in or calculating the missing values. So 0.53 to make 0.17. So we can, if your maths is good, then you can just subtract those two and you should get 0.18. All right. We can go across this row here from 0.18 to 0.35. We should need 0.17. We can come down this column here from 0.17 to 0.29. We should need 0.12. And just to confirm, 0.53 and 0.12 does make 0.65. Okay, so we've filled our Kano map in. Now it's the time to pull the information out of it to answer A and B. Find the chance that a student selected at random is not Australian by birth. So this is the B event, and it's the not B. So that one should be this one here, 0.29, not B, 0.29. So we have a 0.29 chance that the student is not Australian by birth. Find the chance that a student selected at random is not Australian by birth and does not participate in sport. So we want not B intersection not A, which was the first event. Okay, so we need to find that region in the Kano map, which is this one here. So it's this 0.17. So 0.17 chance that the student is not Australian and doesn't do sport. Okay, so it's really important that we, first of all, understand where these regions go into a Kano map. We understand the ideas behind them, adding to one, and we can fill one in and use it to answer some questions. All right, so give them a go.